Alright guys, just a heads up before the video, a lot went wrong in this one, and unfortunately you won't get to see this engine starting in this video because unfortunately I'll need to do a big repair on the engine before it even starts. But everything on the electronic side was right and the engine should have started if it hadn't been for this mechanical failure. So yeah, I decided to upload this video for now. More on this issue at the end of the video. Part 16 of Project E55 ASL, and in this video I'm going to be starting off by finishing up on some of the things that are left over since the previous video, like connecting all the brake lines, connecting the clutch line, basically finishing up on the systems of the car, and then finally starting work on the electronics of the car, installing a standalone ECU and AM Infinity. So hopefully by the end of this video, if everything goes according to plan, you guys should see this engine running. That is a bit of an if as of now because I'm not sure how well the AM Infinity is going to go along with this engine. But the only way to find out is to actually wire up everything and try to fire up this engine, and let's see what result we get. So yeah, definitely really excited for this video. Let's see how everything goes. Starting off by going over some of the things that I've done since the previous video, which is not an awful lot, but I've still done some finishing up on a few of the systems. So I did some finishing up on the fuel system, like I connected all the fuel hoses, the pumps, and I also ended up using a surge tank. So I ended up making my own surge tank, and it's actually a pretty good system. Like the way it works is that there's one pump over here that takes the fuel from this fuel tank and it puts it in the surge tank, and then this second pump actually sucks fuel from the surge tank and gives it to the engine. So this way, even if that outlet on the main fuel tank is not getting any fuel, like if the fuel is splashing around or if I'm going through a corner and all the fuel is accumulated on one side of the fuel cell, this surge tank will still have fuel. And the way it works is that the fuel actually like spins around in a circle in this surge tank. So the way it works is that no matter how much G-force there is, it always makes sure that there is some fuel on the inlet of that fuel pump, and it basically eliminates any chances of fuel starvation that way, even when there's really low levels of fuel that you're running in the car. Other than that, I also started some work on the electronics. Like I started putting this electrical panel together, but there's still a lot more work that I need to do on this. Like I need to make all the connections, like coming from the engine, connecting them to the standalone ECU. This is an AM Infinity, by the way. Like I think I probably already mentioned that in the video. But big thanks to VRP. They were actually the people that gave me a pretty good deal on this ECU, so that's why I was able to get it really early on in the project. And I actually did some figuring out with this ECU already, like reading up on it and making sure what connections I needed to make to get this thing running. So all that will be really helpful in this video. But anyways, the thing that I have to get to now is actually putting all the brake lines together. So for the brake lines, it should be fairly straightforward. These are the brake lines that I'm planning to use. These are, I forgot what the exact material is. It's nickel something, but they're not steel lines. Like the brake lines that you'll find in most cars, they're steel lines that look something like this. They're made of steel and they're coated with this green looking thing so that they don't get rusted. But these lines don't have any coating on them, and they're not supposed to get rusted over time. That's the benefit of these lines, and they're also softer and they're easier to work with. But I've never tried them before, so let's see how they actually go. For connecting the lines to the calipers, I'm going to be using these steel braided brake lines. So because the front ones are like exposed, that's why I don't want them to get damaged. Actually, for this wheel, I have already put the brake line in place, so this is how it looks like. This is how it goes on the wheel. All you need to make sure is that when you turn the suspension to all different positions, like this brake line doesn't get pulled too much or it doesn't hit anything. For making the brake lines, I just used this brake line tool that I had. So it comes with a brake line cutter that is used to cut the brake lines to size. After that, you use a flaring tool to flare the end of the brake line, or well, you put the fitting in first and then you flare it. Now for this one, I was just doing a simple single flare, but for other places you might need to do a double flare or a bubble flare. So just make sure to do the appropriate flare for whatever fitting you're using to screw the brake line to. And then once all the brake lines were cut to size and flared, it was just a matter of bolting everything together and also bending the brake lines on a few places. Once the brake lines were made all the way to the firewall, I had to drill a few holes in the firewall so that I could pass the lines into the car. And while I was at it, I also drilled a few holes for making the mounting points of the clutch fluid reservoir and also the brake fluid reservoir. And once all that was done, it was on to the rear brakes. So the same process, the steel braided brake lines were going to the calipers and all other things were just the same nickel copper lines. So after a few hours of fiddling around with the brake lines, I have managed to connect everything. And just to show you how the braking system works on this car, actually I'll just start with the brake pedal because that's really where everything starts from. So this is actually pretty typical of what you'll find in most race cars. They will have two master cylinders over here and two different brake circuits. It's not the same system you find in production cars. In production cars you will find one master cylinder that has two pistons inside it, and the way the brake circuits are divided, they are actually divided between the front left tire and the rear right tire. Like that's going to be one circuit, and the other one is going to be that tire and that tire. So basically the corners of the car are linked so that if let's say you lose a brake line on that section, you will lose that front wheel and that rear wheel, but you will still have that front wheel and this rear wheel. But in race cars, the way it's linked up is that you have two master cylinders. This is big to give you a true brake bias adjustment so that you can actually change your brake bias by pivoting like which master cylinder the brake pedal controls more. So there's going to be a knob that I'm going to mount somewhere over there, by turning which I will be able to adjust my brake bias front to rear. And the way the brake circuits are hooked up is that one of these lines is going to the front. So this line is actually going to the front brakes on my car, and then that other line is going to the rear brakes. I've used rubber lines over here because my pedal box is adjustable, like it can move forwards and backwards. That's why I've had to use rubber lines so that they don't break when I move it forwards and backwards. And these lines extend all the way to here, where they change to these nickel copper lines, and this line goes to the front brakes. So it's just one line that is coming from here. It goes to this T at the front, and then this T actually splits it to this caliper, and then one goes to that caliper. Same with the rear brakes. This is the line that I'm using for the brakes at the back. So this line goes all the way to the back from over here, and then there's that T over there. So from that T there's a line coming out of here, and that line goes to this caliper, and then the same thing on the other side, that line is going to that caliper. So it was actually a fairly easy braking system to hook up, because there's also less brake lines required this way, rather than in production cars where there's going to be two brake lines coming from the front and going to each rear tire. In this one there's only one brake line, and then it's teed off into two brake lines, so it's a little easier to hook up too. And while I was working on the brake lines, I also connected my clutch line. So this is my cylinder for the clutch. So this is the clutch pedal, and this is the reservoir actually for the clutch, where the clutch fluid is going to go. The thing that I have to do next is that first I'm thinking of getting the clutch working. So for getting the clutch working, well, first I have to fill fluid in this clutch reservoir, and after that I will have to bleed the clutch system, which is a really annoying job because you have to go underneath the car. There's a small bleeding nipple on that clutch slave cylinder over there, and then I'll have to press the clutch. But actually I'll show you, I'll just do it and show you guys how it's done. So for getting the clutch working, I just started off by filling some fluid in the clutch reservoir. After that I had to get underneath the car, and the really annoying thing about this 350Z transmission is that the clutch slave cylinder, where the bleeding thing is located on it, it's not actually the highest point of the clutch. So the only way I find to bleed it properly is to actually remove the whole thing from the clutch, then point it in a way that that bleeding screw becomes the highest point of the slave cylinder, and only then the bleeding works. The thing you have to do for bleeding the system is that you press the pedal down so that all the fluid, along with hopefully the air, comes out of the bleeding screw, and then you tighten the bleeding screw again so that it's sealed again, and then you release the clutch so that the clutch sucks in new fluid from the clutch reservoir, and then you press it again and repeat the same process until you're sure that no air is left in the system. After the clutch was working, there was one more really important step. I had to find out where the clutch engages. I was doing that by pressing the clutch pedal and moving the drive shaft by hand, and making sure where was the point where the clutch was fully disengaged, and then I had to add a stopper over there so that the pedal stops there and it does not go any further, because this pedal box obviously was not meant for this transmission. So I had to adjust the travel of the clutch pedal with the travel of the clutch, because if I didn't do that, it could be possible that the clutch pedal moves so much further down that it damages the springs on the clutch, like it takes those springs beyond their normal travel. This would be necessary whenever you're using a clutch pedal from a different car for an application that it's not actually meant for. And once everything with the clutch was figured, it was onto the brakes. So the same process, I just started off by filling some brake fluid, and this time I did have to get an extra hand for bleeding the brakes because it's pretty difficult to do it by yourself. You can do it by yourself if you really want, but you just need to pressurize the brake reservoir. You need to put pressure in it so that brake fluid constantly keeps coming out, and then you can bleed the corners one by one. Also, I gotta say big thanks to Astro Tools. They commented on the last video that they wanted to send some tools, and they sent a whole bunch of tools, like this whole box full of stuff. It's an area riveter, a belt sander, and a lot of drill bits, and a lot of other useful stuff that is going to be really useful for this project. So yeah, I'm definitely going to be putting these tools to use in future videos. So big thanks to Astro Tools for that. I will link their website in the description below. You can go check them out. So after bleeding the brakes and the clutch, now both those things are working. For the clutch I've had to add the spacer at the back because this clutch pedal was way too deep. Like if I pressed it down all the way, it would have definitely ruined the springs on my clutch. Other than that, yeah, the brake system is also fine. The only thing I don't like about this pedal box is that these pedals are way too deep for a race car. Like usually on a race car you would prefer pedals to not have that much travel. So that's the only thing I don't like about it too much. I think that's something that, I don't know, I'll drive the car first. If it bothers me too much, then I'll probably end up modifying that or changing it entirely. But other than that, functionally everything is looking good, everything is working. So next what I have to move to now is the electronics. So I'll start off by wiring up this AEM Infinity, and then after that I will have to get to tuning it. Now there's a bit of an issue I'm having right now that I can't install the software that I need for actually programming this ECU. But for now I'm gonna start by wiring everything, because even that is gonna take a while. Like I have to wire all the wires coming from the engine to this ECU. So for wiring up the standalone ECU, I will need two pieces of information. One is the wiring diagram for the engine wiring harness, and the other thing is the pinout diagram for the Infinity, like the thing that tells me what pin on the Infinity does what. This engine wiring diagram is not too critical. Even if I don't have this, you can still continue to test all these pins and see like which connector they go to on the engine, and find it out that way. But the pinout on the Infinity, you absolutely need to know that, otherwise you won't be able to connect it properly. Like you wouldn't know which pin does what. So first I will start off by actually cutting all these wires off and then labeling each wire, like what each wire does, like what thing on the engine it goes to. And then once I know that, I can actually put those wires in this connector that is for the AEM Infinity. So after that followed a few painful hours of cutting apart my own engine wiring harness. So I was labeling each wire after making sure what thing it was connected to, and then I was just cutting it off from the factory connector. And yeah, the same thing until all the wires were done. Here's a look at everything after a few hours of cutting all the connectors apart. And this is what the wiring harness looks like. I've actually organized it in a few of these bundles so that it's easier to make all the connections. If it's all just one big bunch of wires, it's really difficult to know which one does what. So the way I've divided it is that all these wires are the wires that I will not be connecting to the AEM Infinity, because there are things like things that need to go to relays, or the air conditioner solenoid that I'm not using, the alternator that I will be using, but I'm not sure which signal to give to this one, so that's something that I will have to figure for later. And also the powers for the ignition coils and stuff. So all that is stuff that I will need to connect with the relays and stuff, and some of it I will need to figure out what to do with it. And all these wires are the wires for the various different sensors on the engines, and also the power wires for those sensors, so the 5-volt powers and the signal ground wires. Signal ground, you can't connect it directly to chassis ground, by the way. Don't make that mistake, because your signals will then be all over the place. So signal ground actually needs to go to signal ground on the Infinity. And then these are all the wires for the injectors, so 8 of these, because there's 8 injectors. And these are all the wires for the ignition coils. Now these are going to be 16 wires, because each of these ignition coils actually controls 2 spark plugs, so there's 2 wires coming out of them. And after that, these are all the wires that I'm not going to be using. So they are for things like, let's see, what is this? The oil level sensor. So I'm not going to be using the stock oil level system, because it's not going to work with the AEM Infinity. It's something that is specific to Mercedes. And also other things like the supercharger recirculating valve. There is no supercharger recirculating valve anymore, because there's no supercharger. And also these wires for the O2 sensors and stuff. So all these things are the things that I'm not going to be using anymore. So now that I have all the wires organized and labeled, next what I have to do is that I have to follow the pinout diagram on the AM Infinity and basically connect all these wires into this one connector, because rather than the Mercedes way, like Mercedes used 3 different connectors or 5 different connectors going to the ECU, on the Infinity there's just one big connector that has 80 pins, and then all these wires need to go to this connector, and then this one will be plugged into the Infinity. So let's say injector 7 over here, so it says C13. C1 means connector 1, where there is only one connector, and then 3 is pin number 3. So pins, the pins should be labeled on the connector, so you'll find a 1 somewhere on the connector, like it says 1 over here. That means this is pin 1, and then you just count from there. So 1, 2, 3, this is pin 3. That means that the wire for injector 7, which would be somewhere over here, this wire, so it means that this wire, I will need to first crimp this wire and put one of these things on it, and then I will be putting this terminal in pin 3, and then do the same thing 80 more times for all these other pins, and then just hopefully plug this in the Infinity, and the Infinity should be able to control everything on the engine. So after that, I started off by stripping these wires so that I could crimp these pins onto these wires. These are the pins that will need to go in the connector for the AM Infinity. Now in this video I was using the 1.4 setting, but later I realized that the 1.8 setting works much better for these pins. Like, it makes it a lot easier to put these in the connector that way. This was the first one that I was doing, that's why I was still a little novice at this. And once all the wires were crimped, all I had to do was put these pins in the appropriate locations in the connector, which is easier said than done, because these were extremely difficult to put in, because, well, this connector really wasn't meant for, I think, wires this thick, because this Mercedes wiring harness had wires way thicker than that could realistically be put into this plug, so it was really difficult putting all these wires in. So after a really long day, I finally managed to put most of the wires in this connector, and this was actually the worst job I think ever, because this connector is just the worst connector ever. Like, the combination of these fat Mercedes wires with this little connector and these tiny pins, it was really difficult putting these pins in. Like, it took a lot of effort, and plus I made a few mistakes initially, like when I was putting the pins in, and I had to remove the pins then, and removing the pins is even worse than putting them in. But anyways, the part that I am at right now is that there's a few wires that are still left, so the wires for the ignition coils, and the wires for a few other things. Like, these are all the wires that will need to power up the AM Infinity, and also the ground wires. So there's a few different ground wires that need to connect the chassis ground. You will always see multiple ground wires and sometimes even multiple power wires on these ECUs, because the thing is that one of these pins can only handle, like, I think 5 amps or something, and that's not enough to power everything that the ECU needs to power. So that's why you'll see multiple ground connections, so that it can draw enough ground and not burn one pin if the ground is only connected to one of the pins. So the step I have to get to now is wiring up these ignition coils. And the really weird thing about this AM Infinity is that it doesn't have anything internal inside the ECU to power these ignition coils, so I will need an external circuit along with it. Now, AM does supply ignition coil drivers that you connect with this ECU, and, well, you still have to wire it up anyways. The reason I didn't go with those ones is that I wasn't sure of something. It's that this engine has 2 spark plugs per cylinder, so it's 16 spark plugs in total. And the ones that AEM supply, they're obviously meant for the regular ones, like 8 plugs for the whole engine. So you need 2 of those drivers for a V8 engine, but I'm guessing for this one you would need 4 of those drivers, because there's 2 spark plugs. So rather than bothering with that and trying to figure out what I needed, I decided to make my own circuit for that. This one is, these are MOSFET drivers. They can power up to 30 amps, so they will easily be powerful enough to control 2 of these ignition coils. Like, one of these transistors can power 2 of these ignition coils. So I put the circuit together really quickly, and it's just a simple circuit really. It's just these MOSFET N-channel transistors that will get 5 volts from the Infinity, and then they will be powerful enough to hopefully control these ignition coils. But first I need to put the circuit together, and I need to actually test whether it can actually fire the spark plugs or not. So a few minutes later, and I've just wired everything up to test out the circuit, and this is a really sketchy way of doing it, by the way. So I have a battery over here for supplying 12 volts to the ignition coils. So the ground wire is actually linked to ground on the turbo, which is the ground for the engine and the whole chassis. It's all connected together. And I've taken one of the spark plugs out, and the spark plug leads actually, and this is the spark plug over here that I've clamped to the exhaust, because the exhaust is also grounded, so that's how it's getting the exhaust. And I've also grounded my circuit that is then connected to this wire. This wire is the wire for actually two of these wires. These are the two wires that will control this spark plug and this spark plug. Now in the E55, these two spark plugs were going to do separate pins on the ECU so that it could control the spark plugs, how they fire. But what I found it was part one of the video series when I was probing around and making sure how all the electronics work, I found out that both these spark plugs get the same signal almost like all the time that I measured it. They were getting the same signal, so I'm not sure why they even bothered making two separate wires. Why not just make one wire? Probably just for reliability, so that if one part of the circuit fails, the other one can still keep working. At least that's how they do it in airplanes, but in this one it's being used for fuel efficiency, not for reliability as a main purpose. But anyways, yeah, getting to the point here. The way I've done it is that I've just linked both these wires together, and then I've linked the red wire to this one. This is the wire that is from this transistor, and this is the transistor that should be controlling, well, the signal from this wire. So yeah, basically what I've done is that if I give this wire 5 volts and if everything is working, it should make this spark plug spark, and if the spark plug does spark, that means that my circuit is working. Now the problem is that that 5 volts only has to be supplied for like 2 milliseconds or something. If I give it for too long, I will burn my ignition coil. If I give it for too short, the spark plug wouldn't spark. So that is a bit of a risky thing to do. Definitely don't do this yourself, but I have a few spare ignition coils, that's why I don't really care. So yeah, let's see how it goes. For giving the circuit 5 volts, I was just connecting two leads together to give it that 5 volts, and I would disconnect it really quickly so that it wasn't long enough to burn the ignition coils, and it definitely isn't a good way to do it. If I had more time, I would have been using a function generator or a microcontroller circuit or something to do this, but since I didn't really care, I just did it this way, and the initial attempt didn't really work, but after making a few changes to the circuit, it did work and the spark plug did start firing. After this, I made an aluminum case for the circuit and then just put it underneath this whole electrical panel. And then I had to get to some wiring again to wire up this thing to all the rest of the wiring harness. Here's a look at everything after, well, almost all the wiring is complete. I've wired in the ignition coil drivers. The circuit goes over here in this box. And then the output leads go to the wiring harness. All of it looks really messy right now, but I'm going to duct all these wires and make it all really neat once everything is tested. But right now I don't want to do that because I haven't even tested everything and I don't even know if the connections are right. So it's the next day now, and I did manage to find a laptop on which Infinity Tuner works, and in fact I have it open right now. So the next thing I have to do is actually connect the laptop, well, connect the ECU to the laptop, and then actually like configure the ECU, tell it what fire pattern the engine has and everything, so you can actually run the engine, hopefully. And since yesterday I've also done a bit of work on the wiring, so I've added this positive lead that goes all the way back to the battery. Well, it's not final right now, I need to still clamp it down and everything, and also finalize all these wires because it's a real mess right now. But anyways, this positive wire goes all the way to the battery at the back, which is on the floor right now, but later I will be mounting it in a proper mounting place. And the positive leads comes from over here. It goes to this connector, which also needs to be covered, and it goes through the starter into the alternator. All the relays are also wired up, so yeah, hopefully now when I give the car power, and well, I also added the switch box over here, so this is the switch for controlling all these relays and stuff. So hopefully, yeah, when I give this car power and I turn these switches on, everything should turn on and I should be able to crank the engine and everything. Like all the connections are made, I just need to check them. I'm not sure if they're right now. So after this, there was a bit of work to do in the software to actually tell it all the specifications of the engine size and everything, and also then get to checking the ignition timing with the strobe gun so I could set it properly so that the ECU knew where 0 degrees was, so that it could change the ignition timing accordingly. And after that, I had to get to calibrating all the sensors. So for the manifold pressure sensor, I just used a bicycle pump and a pressure gauge. I'll talk more about the software part in the next video because there's still quite a bit of tuning left on the engine. So if you guys want to see more details on this, I can also include that in the next video. Okay, so it's the next day now again, and I spent last night configuring the Infinity, like connecting all the sensors and yeah, doing everything in the software, like entering the fire pattern and everything. What I could not do last night though was start the engine because it would have been so loud that it would have woken up half the neighborhood. And the other reason was that I did have a bit of a problem. This radiator hose actually blew out. I was just pressure testing the whole cooling system, just putting pressure in it and making sure that it's fine, like it seals properly, but it didn't seal properly. This Mercedes hose, it came out, like this is actually a crimped fitting, like this hose is crimped into this part, so it's not like I can fix it or anything. It's just one piece. If it fails, you have to buy one new from the dealership, and that's unfortunately what I have to do now. So I already did order the part. Actually, it's gonna be in Monday, and the new one again, then I'll have to cut the hose off from here and just run it with my hose. So yeah, that really sucks that it happened at this point. So now I will still be starting this engine because I really want to test out these things, and I don't want to wait till Monday because I really do want to get done with this video, and I do want to start the engine up for this video. Okay, so here we go. Finally time to actually see if any of this works. I know I'm super nervous right now after all the problems that I've had, the radiator hose blowing off, all the software issues and everything. Yeah, this is power and ignition are already on. I just gotta turn on fuel. Alright, let's see. Nothing. That's funny. Let's check the values again. It's no, nothing at all. After that I made a few more failed attempts on starting the engine, and nothing was making sense. Like the engine didn't even sound normal. Like if you remember from the way the engine sounds when I started it last time, the engine sounds completely different. This is not the way this engine sounds, so something was definitely wrong. But I didn't know what it was and whether it was electrical or whether it was something mechanical. I didn't suspect that it could be anything mechanical because obviously I rebuilt this whole engine and then I started and tested it and everything was fine then. So this was really weird, and I was checking a bunch of electrical things. I took out the plugs a couple of times, put them back in. The plugs were getting soaked with fuel too, so I thought that was definitely an issue, that the fuel terms were off, which they were actually off, but that wasn't the only issue. Okay, unfortunately a lot more bad news for this engine. I was trying to start it and the engine still wasn't starting after a lot of effort, and I decided to take the spark plugs out and do a compression test just to make sure that there was no mechanical problem. And it turns out, well, there is also a mechanical problem. At number 6 there's no compression. I'm only getting like 40 psi of compression, whereas it should be 150. That's what I'm getting on all the other cylinders. So yeah, that is definitely, there's definitely an issue there. It's either gonna be, it could be a lot of things right now, to be honest. It could be a valve that's not sealing properly, it could be a broken piston ring, it could be a broken piston, it could be a bent connecting rod, it could be any of those things, to be honest. I'm just gonna wait to take this engine, like take this head off at least, and then see what's wrong inside it. But anyways, yeah, for sure now this engine's not gonna be starting in this video, so this is gonna be unfortunately the end of this video. It was a lot of work with no result at the end, and yeah, what can I say. Just one more thing for this video, I did end up taking this valve cover off and also the manifold off, my Lamborghini door opening style intake manifold. Well, that's fortunately one good thing about the engine. It is extremely easy to take apart. It just took me 10 minutes doing all this, and I did figure out the problem. Now luckily it's not a bent connecting rod or any of that. The problem is actually just something that got sucked into the engine. Something got sucked into number 6 on one of the valves. I'm not sure if you guys are going to be able to see it on the video, but there's a small piece of metal on one side of the valve. But the problem is that it is inside one of the valves. Well, luckily it didn't go into the engine. It could have done more damage if it got sucked in all the way, or maybe it would have just burnt off. It's one of those small pieces, like of something that I drilled, I think, and it fell out. It could be steel or aluminum, I'm not sure what it is. Well, there was a lot of drilling and stuff going on over here, so yeah, that's it's completely possible that it got sucked in. But the problem is that I still don't know how to get it out, whether I should attempt opening this valve and just taking it out by hand, or whether I should remove the head and do the proper thing, like take the valve out and remove the piece and then check the valve if it's not bent. So yeah, I still haven't decided that. If you guys have any suggestions on that, let me know in the comments. But yeah, thankfully it was just a minor thing, but it is going to be difficult to fix still. But yeah, that's the repair of this is now going to be coming for the next video. Anyways, yeah, I'm going to end the video here. There's no point in not uploading this video now, because any repair or anything that I do on it, it is going to take a while to do it and then to start the engine. So yeah, that's unfortunately everything for now. See you guys in the next one.